Welcome to my YouTube channel. Heat changes associated with chemical reactions. This is the part 2 of the lesson. In part 1 lesson, you have learned exothermic reactions, endothermic reactions, heat change of a chemical reaction delta H, enthalpy diagrams. Finally, you have learned to find out heat change of a chemical reaction experimentally. If you didn't follow that lesson, it is better to follow part 1 lesson. Then you can follow this lesson. In this video, I am going to discuss revision questions with you. Now we'll discuss some simple questions to make a revision. Fill in the blanks using suitable words. Number 1. Temperature of the solution is blank when sodium hydroxide is dissolved in water. Number 2. Temperature of the solution is blank when glucose is dissolved in water. Number 3. If the change in temperature is theta, the mass of the solution is m, the specific heat capacity is C, and the heat change is Q. Q equals blank. Number 4. Reactions which release heat during the reaction are called blank reactions. Number 5. Reactions which absorb heat during reaction are called blank reactions. Now we'll refer to answers. Number 1. Temperature of the solution is increased when sodium hydroxide is dissolved in water. When sodium hydroxide is dissolved, heat is emitted to the environment. So temperature is increased. Number 2. Temperature of the solution is decreased when glucose is dissolved in water. When glucose is dissolved, heat is absorbed to the system. So temperature is decreased. Number 3. If the change in temperature is theta, the mass of the solution is m, the specific heat capacity is C, and the heat change is Q, then Q equals mc theta. Heat loss or gain equals mass into specific heat capacity into change of temperature. Number 4. Reactions which release heat during the reaction are called exothermic reactions. Number 5. Reactions which absorb heat during the reaction are called endothermic reactions. Now answer number 6 to 11 questions. Number 6. In an blank reaction, the energy in the product is less than that of the reactants. Number 7. In an blank reaction, the energy in the product is greater than that of the reactants. Number 8. When change of heat associated with the reaction is stated, it is necessary to indicate the blank state of reactants and products. Number 9. Write down an equation to express delta H of a reaction. Number 10. Why does the value of delta H become negative in an exothermic reaction? Number 11. Why does the value of delta H become positive in an endothermic reaction? Now we'll refer to answers. Number 6. In an exothermic reaction, the energy in the products is less than that of the reactants because when reaction is taken place, heat is emitted to the environment. Number 7. In an endothermic reaction, the energy in the product is greater than that of the reactants because when the reaction is taken place, energy is absorbed to the system. Number 8. When change of heat associated with the reaction is stated, it is necessary to indicate the physical state of reactants and products because according to the physical state, the heat change can be changed. Number 9. Write down an equation to express delta H of a reaction. Delta H equals energy of products minus energy of reactants, HP minus HR. Number 10. Why does the value of delta H become negative in an exothermic reaction? Energy of reactants is greater than the energy of products. So delta H equals HP minus HR. It is a negative value. Number 11. Why does the value of delta H become positive in an endothermic reaction? Energy of products HP is greater than the energy of reactants HR. Delta H equal HP minus HR, so it is a positive value. Now answer the question number 12. The three solutions, sodium hydroxide, hydrochloric acid and sodium chloride of concentration 1 mole per cubic decimeter, are put separately into test tubes A, B and C. Part 1. The test carried out by a student to identify the solutions separately and the observations made are given in the table. Test 1. Dip red and blue litmus papers in the solution in tube A. Observations. Blue litmus did not show any color change. Red litmus turned to blue. Test 2. Dip red and blue litmus papers in the solution in tube B. Observations. Red and blue litmus did not show any color change. Mention the solutions in test tubes A, B and C respectively. Now refer to the test 1. Solution A. In the solution A, blue litmus did not show any color change, but red litmus turned into blue. So A should be a base. So A is the sodium hydroxide solution. Now refer to the test 2. In the solution B, red and blue litmus did not show any color change. No color change in litmus, both litmus. So it should be a neutral solution. So P should be sodium chloride. Then C should be hydrochloric acid. Now do the part 2. When 100 ml of each of the solutions, sodium hydroxide and hydrochloric acid stated above were mixed in a thermally insulated vessel, the temperature of the mixture rose up to 5 degrees Celsius. Part A. Write the balanced chemical equation for the reaction between sodium hydroxide and hydrochloric acid. This is an acid-base reaction. Sodium hydroxide is the base, hydrochloric acid is the acid. When an acid reacts with the base, always it forms a salt and water. So sodium hydroxide reacts with hydrochloric acid and forms sodium chloride and water. So this is the balanced equation. NaOH plus HCl forms NaCl plus H2O. Part B. Calculate the heat change associated with the reaction mentioned above. Take the specific heat capacity of water as 4200 joules per kilogram per degree Celsius and the density of water as 1 grams per cubic centimeter. Here the total volume of the solution is 200 milliliters. Density of water is 1 gram per cubic centimeter. So mass of the solution is 200 grams. Then you can apply the equation Q equals mc theta. M is the mass. Mass is 200 in grams. In kilograms, 200 upon 1000. Specific heat capacity 4200. Change of temperature is 5. So you can apply and simplify. Then you will get 4200 joules or 4.2 kilojoules. So heat change equals minus 4200 joules or minus 4.2 kilojoules. Now refer to the part 3 of the question. Write two assumptions that you made when determining the heat change associated with the reaction between sodium hydroxide and HCl stated above. No heat loss occurs or heat produced is totally used to increase the temperature. The specific heat capacity of the mixture is equal to the specific heat capacity of water. Density of the mixture is equal to the density of water. Now you can stop the video and answer the question. After answering, you can continue video to correct your answers. An experiment was designed to determine that heat change associated with the following chemical reaction. NaOH solid state plus HCl aqueous state forms sodium chloride aqueous and water in liquid form. In the experiment, 50 cubic centimeters of a dilute hydrochloric acid solution were taken into a beaker and 2 grams of solid sodium hydroxide were added to it. Then the mixture was stirred so that the reactants mix well. The initial temperature of the mixture and the maximum temperature of it were recorded. Part 1. State and evidence in support of the fact that a chemical reaction between NaOH and HCl occurred here. Beaker getting heated. Rise of temperature in the reactive mixture. Part 2. Taking the mass of the reaction mixture as simple m, its specific heat capacity as C, and the observed temperature change as theta, write an equation to calculate the heat change Q occurred in the beaker. That is Q equals mc theta. Now part 3. What is the amount of sodium hydroxide used for the experiment in moles? You have given the relative atomic masses of sodium, oxygen and hydrogen. Molar mass of sodium hydroxide equals 424 plus 16 plus 1 in grams. So that is 40 grams per mole. Then number of moles of sodium hydroxide equals 2 upon 40. That is 0.05 moles. Part 4. The heat change occurred in the beaker during the experiment was 3 kilojoules. What would be the heat change when 1 mole of solid sodium hydroxide completely reacts with a dilute HCl solution? Heat change associated with 0.5 moles of sodium hydroxide is 3 kilojoules. So heat change associated with 1 mole of sodium hydroxide equals 3 upon 0.05. That is 60 kilojoules. Part 5. This experiment conducted in the school laboratory is based on several assumptions. State one assumption made in each of the following instances. A. Determining the mass of the solution. The density of water being equal to that of reactive mixture. B. Assigning a value for specific heat capacity of the solution. Specific heat capacity of water and the solution are same. C. rise in temperature of the reaction mixture. The total amount of heat produced by the reaction is used up to increase the temperature of the solution. No heat loss occurred. Part 6. The above experiment is erroneous due to loss of heat. Suggests a measure that can be taken to minimize this error when conducting this experiment in the school laboratory. The reacting component should be covered by a heat insulator such as cotton wool. Now answer this question. Part 1. The energy change delta H of the reaction taking place between calcium carbonate and hydrochloric acid is minus 61 kilojoules per mole. Part A. Is this reaction exothermic or endothermic? This is an exothermic reaction. Part B. Give reasons for your answer. Heat change of the reaction is a negative value. Energy of reactants is greater than energy of products. So energy is released to the environment when the reaction is taken place. Part 2. Complete the following energy diagram with regard to the reaction taking place between calcium carbonate and hydrochloric acid. This is an exothermic reaction. So energy of the reactants is greater than energy of products. So calcium carbonate and hydrochloric acid should be at the upper level. Calcium chloride, water and carbon dioxide should be at the lower level. When the reaction is taken place, calcium carbonate reacts with hydrochloric acid and form calcium chloride, water and carbon dioxide. Delta H of the reaction is minus 61 kilojoules per mole. So this is the energy level diagram or enthalpy diagram. Now we have come to the end of the lesson. Subscribe my channel and click the bell icon. Then we'll meet again in another lesson. Thank you.